Alright, this is week 9 of my final year project progress. This time I had to hang the rig vertically. I'm going to lift the load vertically. I'm going to move this. I attached it very securely, yes, very professional to this, to the whole table, so it's able to lift the load up and down. And we ditched the pulley, and now the load just directly pulls onto it. And this kind of looks like the issue that I had with inconsistent load weights on the load cell over there. So hopefully that's going to be fixed. You'll see in a bit the output data, and it's looking quite good. And as you can see, is it going to lift? Or did I put it only for one cycle? Yeah, it's lifting with steps of 60, with increments, with very small increments, and it waits like 1 second per increment. And it's going to do that for a few times, average it, and hopefully we can get some really good data at the end. Good stuff. Alright, so this is week 9 progress on my final year project. So this is the calibration rig we had yesterday. As you can see, we put some more wood in here, make sure it's a bit sturdier, doesn't fall and kill anybody. We got the muscle in there. We changed a few things. First, we have a quick release thing over here, which just makes life a bit easier. This still has to be perfected a little bit because the railing over here comes off a little bit. That's not very good. We also changed the flimsy rope for some nice ferrule crimped wire, so this is not stretching or doing anything funky. We got a carabiner, and we got some actual proper weights in there. We have two 10-kilogram weights over there, as well as a 20-kilogram. So, main idea, this is currently being tested at the maximum load that the muscle can lift, which is 40 kilograms. We got 40 kilograms over here, which thankfully it can do no problem whatsoever. And we're getting the encoder reading. So far, the data looks pretty alright. I'll show it later. Looks pretty good. And yeah, few changes. We shortened the load cell over there. We had to cut the bolt over there. We also added that bracket piece, which let's zoom in there. It appears to be bending a little bit, but it does fix the issue. Oh, it's zooming in on my finger like crazy. But yeah, it fixes the issue of the muscle not quite being parallel. So so the muscle wasn't parallel. Now it is a bit more parallel. And yes, so far so good. Looking forward to the data that we can gather from this, and hopefully it'll be more accurate than the data previously gathered on these muscles, which used some laser rangefinders, which are super noisy. Encoder, much less noisy. Load cell, but the load cell is more of a sanity check than anything, just to make sure that the load is at least consistent to at least within about a kilogram. That way we can get some nice accurate readings for the muscles, and hopefully this can all be good. Alright, so I took some quick measurements, something with like 30 steps with I think like 2 seconds of delay or so. So 2 seconds of delay per reading. And as we can see, ignore this bit. This is what's caused from the linear bearing suddenly jumping as it tries to re-enter back into the railing. So that's something I want to try to fix tomorrow, Wednesday. But so far so good. The variance on the load is pretty alright. So there's not a lot of variance in the load, which is that's good. That's good. That is a control variable that I've been having a really hard time trying to keep consistent. And overall, yes, as you can see, we have the up curve, we have the down curve, some pretty nicely laid out data, not except from this outlier, which again I'll try to fix. I know exact cause of that, but so far so good. The next step is to get readings for 40 kilograms. So well, it's here 43, but oh well, it's the best we have. 43 kilograms, 30 kilograms, 20 kilograms, and 10 kilograms. So 4 ranges of reading should give us a pretty good interpolation range and accuracy, and overall making pretty good progress. Very nice. Alright, so after some more calibration, I managed to get all the pressure to distance values for all the loads, so 13, 24, 33, and 43 kilograms. I managed to get all the curves, which are color-coded, and all the load readings, which as you can see kind of stay on average. So this is the ones for about 10 kilograms, about 23 or 24 or 33, and about 43 or so. And as you can see, they're fairly consistent, which is good, and the curves have a nice shape. There's no outliers, and even then I'm still looking forward to improving the rig a little bit, because currently there's a slight jolt, which is even visible in the data when the it's not shown here, but this comes out, and then when it comes back in, it kind of realigns and goes clunk, which causes a slight spike in the load, which can be visible around here, and that's kind of just what happens. But even then, the load's fairly consistent. The standard deviation isn't too far. The maximum range does not go above like 2 kilograms, and all it's going pretty alright. Yeah, stay tuned for further updates. This will probably all be chunked together into one big video. These are just the recordings for each week, for each day of week 9. Yeah, have a good one. Alright, it is Thursday today, and we have managed to get some data. This is the new calibration data after fixing the jolting issue. So, the issue we had before yesterday on Wednesday, and today is Thursday. The bearings were jolting because they were coming out, and then after going up, they were kind of re-entering into this rail because they were out, and it was clunking and caused like an initial load spike, which I'll show in a bit on the previous charts. But that's been fixed. Both linear bearings have been taken out. The encoder rail has been reset a little bit below just to make sure we have enough clearance. We reattached the encoder in there, and yes, that was done. Some more test measurements were done to more so test the accuracy of the rig against previous. My brain is not working because I've been here for 8 hours straight, and I think it's actually melting. Yes, there were some other calibration tests done right here. So over several cycles just to see kind of the variance, and this overlap in this curve. It's good because it's like many different tiny little curves, and that's good. That means we're getting consistent readings, and these readings, don't worry too much about them. As you see, the scale's not, well, as best as my phone can see, but it reads there that the scale is just varies between a kilogram. So it's not like a kilogram of variance, which is about as good as we can get in the system. And my phone, right? And yes, so some tests were done on that. I analyzed the standard deviation and the range. So the maximum standard deviation was like between cycles for each reading was like 4 millimeters, like 4 point something millimeters. That's the maximum standard deviation, and the maximum range was like 12 millimeters. So that's good. That means we have a accuracy or tolerance within the muzzle of plus or minus 6 millimeters, which is good. It's going to be used in one of those wheelchair platforms. So whether a user is 1 centimeter tilted off or not, it doesn't really matter that much. So overall, good results. Compared to previous student results, they were much noisier and not as good. They were using laser rangefinders attached on the actual platform to actually get the distance measurement. So this is a decent improvement in accuracy. And the encoder does have particularly funny graph right here in my blog, if I can show it right here. This is the noise from the previous student using laser rangefinders. As you can see, lots of difference between the minimum maximum readings. At one point it had like 16, a difference of 16 millimeters. Here it is for the encoder. Taking over 100 snapshots. That's a straight line. So once it makes a reading, that's it. That's the reading. There's an outlier of 1 single millimeter on the end. That's it. So yes, this week has been just charge. Oh yeah, this was the initial chart with the jolting, and so this initial load spike was because as the bearing was re-entering, it was clunking back into place, and it goes like that little load spike you see there. It's even more visible in previous graphs, like right there. That's a spike. And if we go down and we look at the new measurements, that spike is gone. So we're getting nice, much cleaner data. Tomorrow by Friday, I'll see if I'm capable of, because right now the platform is offset by 2 degrees. I will tilt it so it's perfectly level, so 0 degrees, and I will measure the actual effect of that on the data if there is any effect. And overall, yes, I'm hoping by this week I can be done with the calibration data. I can finally just reintegrate it back into my program, and hopefully that'll be the final milestone for this project. So yeah, thank you for watching. I'll probably make a blog tomorrow. Yes. Alright, it is Friday, week 9, and hopefully this is going to be the last set of calibration measurements I'll have to do before I move on to week 9 and I can finally start making use of the calibration data into the final platform. Well, this is not the final platform, this is the test platform. The final platform is yet to be built, but you get my point. It's new calibration data for these muscles, which are bigger, stronger, yes. And yeah, so right now I'm gonna run the final set of calibrations tests. So it's gonna be 60 steps, 5 seconds delay. This I mentioned before that this was offset by 2 degrees. I pulled this back a little bit, and now it is zero point 0.3 degrees, so about as level as I can possibly get it. I'll measure that data, see if there's any significant difference with the previous data, make a nice little bit of analysis, and hopefully this will be pretty much a pretty good step or really good key milestone for my project. Yeah. Actually, yes, I will show the charts in a bit once this finishes calibrating for all the weights. So I have to wait a good while, do the calibration for 10 kilograms, wait another while, do calibration for 20 kilograms, another while 30 kilograms, another while 40 kilograms. So hopefully we can see, once that's done, we can see the charts in a bit. Alright, so after doing all the calibration tests for all the weights, I have the following plots. So if I go to 12 kilograms and click on plot cycles, this is just a quick utility I made to plot all the data with all its different characteristics. But anyways, this is the pressure to distance load cycle. So these are the up cycles. So the darker line over here, that's the that's the down curve. So the blue line's the down curve. Everything that's blue has to do with the down curve. So these are the load readings in the down curve. So you see they're mostly consistent. These are the cycles for the down curve, so they get lighter as they keep going. And as you can see, the first cycle kind of is always offset. So the first cycle, especially at lower loads, and you will see this later, is always a bit of an outlier, and it's always shifted down. It's a systematic error which I still cannot explain too well, but I just know that it exists. In the final calculations, when putting all this back into my main software, I'll take these outliers, like the first 1 or 2 cycles, out. I'm going to take the average values of each. So yes, uh, there's this effect thankfully does dissipate as you keep going. So if I pull up the utility again and go to 13 kilograms, this was actually the same weight, but because it was being held differently with different hardware, there was like a slight weight discrepancy. But so this is the 13 kilograms. Is the most recent one. It's the most recent one. As you can see, the up curve is just the first cycle. It's a complete outlier. And again, this is a really weird phenomenon that I wouldn't otherwise have noted if I didn't just take the effort of saying, okay, I'm gonna plot the cycle instead of just taking the average. And so this weird thing happens, and I'm glad I found that out. And this just means that my data can be more accurate now that I remove the outlier. So as you can see, heavier load, the lines sort of bunch together, and that outlier effect is removed even more and more, and even the load readings become more consistent, which is an interesting effect. Um, and overall, yes, there was a whole lot of trial and error throughout this process. It was so much happened. It was unbelievable. But yeah, 33 kilograms, the lines are pretty much overlapped, and at 44, again, overlapped. So select, plot cycles, bam, almost nice consistent readings. I pretty much don't have to take any outliers out of this. So yes, this is final data. Week 10 will be pretty much taking all this data and adapting it into a useful format that I think I dwelled on a little bit before, but I'll delve on in further detail in some of the future blogs. And overall, yeah, I believe this is it for week 9. I think I covered enough, and yeah, thank you for watching. Have a great day.